what do you think? Is data science software engineering? We're getting a mic here.
Well, it's a great question. I think if you see AI as a tool to actually build intelligent systems, then AI certainly is a part of the software engineering process that makes it possible to actually develop systems without having to hand program every rule that you have. So in that way, yes. But I would still say that normal software engineering is very different from data science. We actually wrote a paper about this, trying to basically identify the challenges from a software engineering point of view with building AI systems. So it's certainly different, but it is connected.
No.
I sort of agree. I think you framed it quite well in the beginning, that it's a sort of a set of capabilities or functions. I mean, software engineering is of course an important part of it, especially if you want to scale it. But also, sort of, I'm focusing a lot on like the boring stuff, just figuring out the core metrics, understanding a business, making sure that we can test models in sort of a live setting, so to say. And that is also important. So I think we need to like divide it across different capabilities and make sure we can scale it.
Robert, your thoughts?
I suppose I'm sort of biased because I came at this whole thing from the computer engineering perspective. In fact, I learned last week that this trick that I was using of segmenting stuff into bins and averaging within each bin is apparently called a kernel method. So I'm doing lots of statistics as well. But I just find that you know, we don't have to say it's software engineering, but being a good computer engineer will give you such a competitive advantage that it's hard to ignore. And for example, you know, you might be implementing this version of your model and you're expecting it to run on a GPU because you need it to run fast. And then all of a sudden in the implementation it says you need to do a cumulative sum. And there's no cumulative sum that's part of the cuBLAS or cuDNN. And anybody that studied computer science knows how to parallelize cumulative sum. It's a dynamic programming algorithm, and so you write your own CUDA kernel, and then that's that. So that takes you about 20 minutes. For somebody that doesn't know basic computer science, it would be an insurmountable hurdle. And so unless you have a team of 30 ninjas with dedicated people doing every single piece, and I'm not sure every company can afford that, I think it does pay dividends to have people that are good at computer engineering. So maybe computer engineering more than software engineering as such, because we're not talking about like Java enterprise software development, but you know, computer chops.
And obviously knowing a lot of Julia would be preferred.
Yes, Julia would make things much better.
Great, thanks so much for your thoughts. So I'm just going through a few of the questions that came in here from last year's and prior to this event. Breakthroughs, no specific. What are the major things you've seen since last year's conference? What are the things you want to highlight for the audience that we might have missed? So should we start again with Anders?
Yeah, and I think I would like to focus on one area, which is the natural language processing part, and the extreme advances we have seen there. So I'm sure many of you have heard about the Google BERT and the Transformer, Roberta, and so forth. We have, I think the latest one is called AdBERT, and we have like XBERT now. All these kind of BERT metaphors is really getting tiresome. But it is, I mean, we have at Peltarion worked a lot with it lately, and we can see that NLP is surprisingly efficient without even having to actually train it on their own data at all the same level as other deep learning techniques has done in the past. So being able to do transfer learning in a truly much more advanced way is a really big change in the way you can build these type of systems. So it's both, not only the accuracy you can get for different NLP tasks today, but also that we actually don't require to have as much labeled data. Even zero labeled data directly from the company can still make it possible to actually deploy a system for different NLP tasks. And I think that's a big change that hasn't been really validated until this year. So I'm really excited about that.
I spoke to our machine learning engineering team yesterday and asked them about this question. They mentioned BERT, and that is something we've tried out to like parsing YouTube video description, channel descriptions, and comments just to see how we can extract data and make our graph more powerful. But otherwise, they more or less said, no, we're working with the stable, proven stuff right now.
I think one of the biggest advances that has started to prove itself this year is a computer engineering technique, which is algorithmic auto-differentiation, both forward and backwards. The idea that you can learn stuff automatically, not just the weights of a neural network, but the input parameters to differential equations, to probabilistic systems, to anything really, is super cool. And so, you know, you might already have your well-established formulas that predict things. Well, let your system learn the parameters by themselves. I think that auto-differentiation is going to be adopted into every big framework in the next year or two.
Great. Very interesting. So let's talk about productionizations of machine learning. What are the biggest challenges today? What are you facing when implementing stuff?
Oh, I guess
well,
I can
let's
start
go
again.
to natural order.
I think you mentioned a large number of the most important aspects that are already in your opening talk, so I'm not going to repeat those. But to build upon, you know, the problems of, you know, you really should expect machines to fail. You need to have the proper versioning. You have the proper auto-scaling in place. All of these aspects is, of course, super important, and you need to have the proper software engineering skills to be able to do that. But what perhaps is otherwise interesting and important, especially if you want to, you know, put some kind of model in production at the company, is to have the right mindset and the right expectations from the stakeholders and the people that are going to use it. I think a lot of people expect AI development to be basically a software development in the sense that once you have built something, it works and it can be put in production and that's done. That's done. That's not really what AI development is. You should instead be really clear that this is an iterative process, and especially if you have a system that is or having some kind of feedback loop, set their expectations right at the beginning and say the first version we will actually put in production will actually not perform that well. But as it continues to collect more data, and as we get more feedback of what works and what doesn't work, it will start to improve over time. And if we say that in the beginning, and instead of being like this you know, really excited data scientists saying, yes, we're going to put it in production, it's going to work awesome. Don't say that. Say that we have a first version now, and with iterations coming in coming year, it will actually start to work really well. So I think that's an important lesson to learn.
Yeah, I think I can agree. It's I think you caught it quite well in the first presentation as well, and that's sort of how we're trying to set it up. I would say we're like in phase 1 and phase 2. So just in the recent year, we have like established my team in product analytics. We have a data engineering team, just getting the data in shape. We have an ML engineering team building the pipelines, making sure that we can like scale stuff when we get it into production. But then also we're sort of figuring out also how to implement it together with our regular product teams and the stakeholders to make sure that we get like go the full mile, so to say. I mean, some of the things that we're looking at now is like classifying our music catalog with different data. But that is probably also want to put like a supervised layer on top of it, where we propose tags and moods and genres and stuff, and then like let our music teams actually like put them really into production, so to say. So it's a lot of integrations and capabilities to build up. And I think, as Anders say, also we try to be very clear in like MVP status on the initial deliveries, whether it's offline or on online tools.
Yeah, I have nothing to add.
Nothing on the GPU side?
GPUs are good.
Okay, great, awesome. If you remember the slide I showed you that AI and value capturing is much more than algorithms and tech. One of the questions that came in is kind of the training for people, and especially people in a management position that are responsible for a product utilizing AI, or a stakeholder in the AI domain that isn't really a techie and algorithmic and this algorithmic native, to phrase a new expression. what should we do? How should we train them? How should we communicate with them? I mean, obviously they've launched this AI course now in Finland and in Sweden, which is kind of training for the larger population, but how can we do more targeted things internally in our companies and workplaces? Should we start from Europe now?
I actually have a really nice example of that where, you know, I was talking to a woman that had a background in physics, and so you would expect her to have a lot of experience with this, but she was very focused on the data collection and the analysis and that kind of thing, and that's not really the type of education that I think the decision makers need. The type of, there was this one decision maker that came and asked me, would it be possible to take an AutoCAD drawing and put it into a model and get out some interesting facts about what the 3D drawing is like from the file? And I thought that's a super creative question, and yeah, it's probably doable. You need a bit of software, but it's totally doable. And his ability to express that problem is the kind of education that I think decision makers need to be able to have. Not necessarily how the software needs to be set up or how the data needs to be collected. That's stuff that then the engineers can figure out. So the type of education I think is necessary is the type that you would have during like a workshop with decision makers where you teach them what's even possible with machine learning.
Great. What can we do with AI and data science that's not done today but would be great for the world? A little bit of futuristic thinking.
If I may, I'd just like to continue a bit on the previous question very briefly, because it's happened a lot of things in just this year, which I think is important. And it is, to follow up on the previous question we had, very important to have the right mindset, not only for the data scientists, but actually for the whole company, and especially the management team. And that is lacking today. We tried at Spotify when I worked there to actually have some kind of course that we could give other data engineers or software engineers to learn how to do proper data science, and even other people. And we couldn't even find it in Sweden. We had to go abroad and then pay a lot of things for a really bad course. But what happened now in recent years is we actually do have a number of Swedish initiatives. One is the AI Competence for Sweden, trying to give at least some money, not a lot, but some money to Swedish universities to actually provide courses from universities that is in a format suitable for companies. And I think that's a really good starting point, even though there are some question marks about the implementation. We have other stuff like the AI agenda, which I'm part of as well. We have the AI innovation of Sweden. So we are starting to see a lot of work in trying to improve this situation, but it is a bad situation and an important one to solve. So back to your...
But Anders, just to make it a little bit more clear, you are involved in these things.
Yeah.
And for people in the audience that are interested in listening more and how they can get trainings, involvement, what should they do?
Well, go to first your universities. Ask, some person there that is actually involved in this AI Competence of Sweden initiative. A lot of new courses has been taken forward that is of a more crash course nature, not like 3 months or 3-year programs that you have to take. And they are created with the mindset of actually being suited for companies. So go and double check that, because it may actually exist today, courses that are directly useful for you. So that would be my first recommendation. Otherwise, we are still developing, especially this AI agenda program that are supposed to, at the end of this year, come up with some set of suggestion for how we can improve it further, because we need to improve it more. I would really encourage you to either approach me or someone else in this initiative to come with your best suggestion. What are your problems? What are your needs? And if we have a better understanding of those, we can make sure that next year, in 2020, we really have a much better situation than we have today. So look up AI agenda for Sweden. You can see we have like 6 working groups, one for industry, one for public sector, and one for education, for research and so forth. And we are going to put up a report end of this year, hopefully guiding the development in this forward. So I really ask you to come up and tell us your problems and challenges.
Great. Daniel, do you have some?
No.
It's good. Everybody in your company is AI native.
For us?
Yes.
No, of course not. But more so than I've seen in other companies I've worked with. It's one of the things that I kind of like that. I mean, we have this sort of full stack mentality. All developers are full stack, which means that a lot of them are interested in machine learning. They're doing that on like hackathons, and some of the models that we actually use and have been developed by the software engineering teams. And there is, I would say also, like, I mean, we're not a huge company. We're scaling fast, and it's also on the like founder level. There is a great appreciation and an understanding of how important it is to like use and get value from the data that we have, which is one of the strengths in the company. So it is very sort of, it's a very good environment. We're not there. We haven't built the tools, but we're investing heavily in it, and it's like, it's invested in a fairly reasonable fashion, I would say, with most of the time, what is called, like, rimliga expectations.
Sounds great. So I'm not going to let this question go, even though I tried earlier, but now I'm circling back because it became extremely interesting. So if I'm having a meeting with one of my stakeholders and it becomes quite apparent that this person has no idea what I'm talking about, how should I try to get that person more understandable of our area? Because I guess just confronting and saying you don't understand what you're speaking about, just trust me, isn't good enough for us. How should we address those type of people? They're still standing on the other side, thinking we just create a black box and that's it. How can we address that? I mean, Anders, you were on a kind of a very large level, which is extremely good on changing society, digital native, and Robert, I mean, you get the opportunity to meet new clients every day, almost.
It is very much a matter, and this is a lot to ask of a person, but it's the reason they don't understand it is because they shouldn't have to understand how statistics and all that kind of stuff works. What they understand is the reality of their business, which is this going to make me money? Is this going to make the business be more efficient? Is it going to be all that kind of stuff? And if you can't explain it in their terms, of course it's not relevant to them. And a lot of times it's sort of left open. Of course it's going to get better, but that's very seldom convincing. And it's not always possible. I know we've spoken about this, you know, to be able to quantify beforehand exactly what the advantage of something is going to be. So if you're lucky enough to be in a company where everybody's open-minded and says, yeah, we're willing to invest 10% of, you know, our revenue in not Bluebird projects, but, you know, stuff with uncertain outcome, then that's good luck for you. But for everybody else that's in a, you know, an established industry vertical like utilities or something, you have your work cut out for you, and you have to do your absolute best to try and, you know, guess exactly what. Maybe that's the thing. Maybe the stuff that has an uncertain outcome is just not worth going after because it's going to be too hard to convince people to go after it. So you need to focus on the stuff where you really can quantify what the potential benefit is. And to tie it back to your earlier question, if you talk about utilities, saving energy. So optimization, we all know this is all about optimization. If you can quantify energy savings, that's money. That speaks to them. You don't have to explain what model or what method or anything you're doing.
I'd just like to add one metaphor or quote from the founder of Spotify. He spoke about failing fast. And I'm not sure if you heard about that concept, but I think it's especially true for AI development. So if I were to speak to someone that is not used to having worked with AI project in the past, if there is something I try to explain to him, it's the concept of failing fast. And what I mean with that is simply, don't choose one POC, one prototype to develop and put all your eggs in that basket, so to speak. Do try to find 10 different prototypes or POCs that you are going to try out, but fail quickly for the ones that doesn't seem to work, where you don't have the predictive power sufficient in the data you have right now. So fail fast for those 10, and in that way you will find the single one out of the 10 that actually will bring true business value. If you start to bring that understanding of how experimental AI development is, because it's so dependent on the data, then I think you will have the right mindset for a lot of stakeholders and people that are not used to this type of work.
Yeah, I think most have been said, I guess. It's sort of these sort of skeptic people come in like different flavors. So I think you need to understand like where are they coming from. I think the most difficult ones are probably the ones that think they understand but don't like have very strong opinions on like how it should be done. And I mean that can be like, yeah, you should develop in Java or like on all kinds of levels. But I mean, in the end, I think you need to understand sort of what the pain points are, try to find a path around it or over it or under it or somehow. But then as Robert said, and yeah, focusing on the value. We should do that even for the ones that are, of course, involved and understand these things, to get the expectations to a reasonable level and make sure that, as Anders said before, that we'll probably not nail it like in the first iteration, but building it over time is an important capabilities. But I think we're trying to push everything to be like very outcome-oriented in everything we do, for business decisions, for non-ML software that we build, because it's not, I mean, and no business is about developing as many lines of codes and putting them on the internet as possible. It's about actually achieving something for our customers and users, and that goes for ML project as well.
I want to be devil's advocate for a second and push back and ask you a question, and that is, do you risk spreading yourself too thin if you have a lot of projects, and one, and two, so it's one thing to do many projects if you have a big team. What if you have a small team of one engineer and one data scientist or something like that?
Well, I would still say you should do it, but it doesn't mean you actually build a fully fledged POC for all 10 of them. It does mean that you should explore the data to begin with, of course, which is the core cornerstone, for 10 potential business value projects, so to speak. But you really don't know until you really examine what is the predictive power in the data you do have today. So if you don't explore at least like 5 or 10 of them, you probably won't find that the one that actually works. And instead you spend like half a year on one that has in no way the sufficient data necessary, and you spend all your time doing feature engineering, and you're trying to do all the tricks in a book, and still it doesn't work. And if you instead had looked at 5 other examples, you would have avoided the situation and actually found the good one.
Well, I think a lot of projects die at the data exploration stage when you realize it wasn't collected correctly or something like that. So,
very good. If we then look at team, and I mean, obviously describing you need software developers, data scientists, but we live in a world where a lot of companies doesn't have these resources yet. What can these companies do to get started quickly without investing a lot in hiring a full stack team with both data scientists, machine learning engineers, having a monthly salary ridiculously above average in Sweden? What are your best suggestions? What tools, what strategies, algorithms? What is the kind of, where would you start if you didn't have a very large budget? Should we start with you, Daniel?
Sure. It's a very hard question, actually. But I mean, I've been in those positions, and I think, I mean, start from the ground up. Just make sure you have the data in a like proper environment. I mean, cloud should be first choice, obviously, today. I mean, just get enough funding to go cloud, and then find some smart like full stack people that can work together and try to build the basics, and then you can like scale from there, I would say. Very poor answer, but
any types of tools?
Don't make it too big.
Yeah. AutoML setup, is there anything that you think could gain some sort of value?
But I think the tools are out there. I mean, you probably need a cloud to be able to run it on like enough scale, depending on the data set size. But I mean, otherwise, I mean, we have everything in Google Cloud. We run Python, more or less, only thing. And then, yeah, containerize everything to make it portable. So like the tools are out there, I think. Just like how to assemble them together into a pipeline is.
So partly agree, partly not. It depends on the type of project. You know, we focus a lot on the latest type of AI techniques, especially deep learning. And we can basically see the tooling there that is out there is made by Google, by Facebook, by Amazon, for Google, for Amazon, for Microsoft. They are not made for the normal size companies. What we see a lot is that we know the big tech companies, of course, that they can do this. They have the researchers, they have the data, they have the infrastructure. But other companies don't have that. So actually what we see most other companies fail when they try to especially make use of the latest type of AI technique. And the tooling around that, I would say, is far too immature today. You know, that's basically, I would really recommend to investigate what platforms you can use, what tooling you can use to avoid having to build everything from scratch. It is much more complicated than going through a Keras tutorial. So when actually applying it for your own data and your own use case, you will get into problems. Just being able to maintain it and keep it up to date will be a real problem. Try to find a high-level, good working platform that can actually be useful for your use case. That's my strong recommendations.
I think the analogy that's most apt here is the one where you say, if you think it's expensive to hire a pro, then wait till you hire an amateur or 10 amateurs. But actually, following up on what you said earlier, it is my experience that people straight out of school tend to work harder, be more clever, be more open-minded and other stuff than experts, because experts already know everything. So I guess the other thing would be difficult in that case would be how to recruit the right people. And there is no easy answer for that. In this case, I think actually the best advice would be to take advantage of the network that's in here. You know, ask people like us, what should a good CV look like? And even after you think you have everybody that's ticked off, you know, React, Hadoop, you know, whatever you want, it can still be. I have a super tough time even looking at CVs. We're like, geez, this guy's worked at the military, at this place, and everything. They look super smart, and then it didn't turn out to be the same thing. So I think the hiring process is the first place where you start to save money.
Yeah. I think there's very good insights. We have 5 more minutes, and I want to talk a little bit more about resources and skills. I mean, finding good resources is hard. We all know it. But what about working with consultants? I'm struggling from time to time finding a good engagement model where you're not being kind of overtaken by consultants, completely skill transfers. What is your experience working with consultancies, and what is the best way to find them and engage with them? So, Robert?
Well, we are a consultancy at LakeTide, and we have a model that we like a lot and that our customers like a lot, which is one where you don't pay by the hour, you pay for results. So they say, we want this model, we want it in production, we want this, and we have this. How can you do it? And we say, oh, based on our expertise, that'll take 2 people 2 months. So that they don't come to us and say, oh, we need 4 people for 3 months to do something, and then we can see if we can squeeze it in. And the nice thing is they know how much that costs. They know our expert opinion on how long we think it'll take. And I think that way of sort of compartmentalizing projects is very nice. The worst thing is when you have an ERP project that's 5 years, and then when it's done, you don't even remember why you started it. And it can be the same thing with AI projects that just drag on forever. And even if you were to be successful, everybody hates you because they don't remember why you started it and all that kind of stuff. I think you need to have stuff that's 3 months or shorter. Even big projects that take more than 3 months to do, you can always break them up into milestones and say, well, at least now we've gotten this far. It's done. Let's move on to the next phase. Let's see if the scope needs to be changed because maybe the circumstances have changed since we started. Yeah.
Yeah, I can quickly just share some experience, partly from Spotify and perhaps also some experience from Peltarion. If I start with Spotify, we had a huge number of consultancies, and we were very dependent on them. And we also recognized after time it costs a lot of money with especially good consultancies. And we made a big decision to try to cut down as much as we could upon them. And it was surprisingly hard. It is very often you don't have the right documentation. It's hard to do the handover. And being able, you shouldn't really outsource the core business that you have without having that kind of skill set in-house. From Peltarion, we basically try to help other companies and build the right platform tooling to make it easier. But we have certainly recognized that some companies need help. Even if you have the model, you need to integrate it into their system somehow. And that is a skill that a lot of companies don't have. So we also partner with consultancies to make sure that we can give them that extra help because they actually rather often doesn't have that kind of skill set to even do the integration work themselves. So I think that could be a good way. I mean, try to have the knowledge and the skill in-house, but do use consultancies, especially to bootstrap the use of AI in your company.
I have nothing more to add. I think more question to Robert, like how you work post-project when it's like in production. What's the engagement model there with your clients?
We have targeted companies that are a bit older and more established because, you know, digital companies like yourselves are already thinking cloud, analytics, and all that kind of stuff. And, you know, utilities companies, they have their old systems and everything. And usually after doing the first thing, which is perhaps maybe, you know, if you make it short, making the data available, that sort of brings up new ideas, and they learn how to value the impact of that stuff. And so I really like this 1 to 3 months sort of projects type stuff. And we really don't want to get stuck anywhere. So we make sure that there's handoff included in the time and all of that kind of stuff. So I think that would be. I would like it if people thought of consultants rather than as buying people. That they bought the exact help they needed.
Perfect of worlds, right? So we are ending now the panel with kind of you guys giving your forecast, your prediction for 2020. What will happen next year?
Ooh. 2020.
Who wants to go first?
More AI API services coming from the major cloud providers. There were so many questions about AutoML from Google on this year's sent-in questions. So yeah, I think easy peasy APIs from the major cloud providers that do more object detection, more of this kind of stuff that's really becoming standardized.
Yeah, so we can partly speak about like different fields, like NLP, of course, that will continue, and we'll see a similar trend as we saw from images from 2012 and forward, and the rapid succession of different use cases in simply for one, ability to use images in very advanced ways today, the similar type of advances we will see for text, and we can't even imagine, I think, today what we can do with text in coming years. So that's super fun and exciting, I think. We do see a lot of problems, though. One is simply building, especially these neural network technologies, hard because it's so complicated architectures. So that's actually one of the things we actually have 2 PhD students now trying to, for one, focus on how can you make that process of searching architectures easier and actually affordable. It shouldn't be super expensive as it is today. I think that is an area that we will see progress in. Another is explainable AI. So today we can actually, AI and deep learning is not a black box that some people think, but it is hard to do it. I think we will start to see a lot more explainable techniques for a large number of AI models, and that will help to build trust in AI and make it easier to develop models in a fast way.
I don't know, I probably don't have very much to add in terms of trends. I think it's like in general, hopefully it keeps maturing another year. And
these questions are hard to answer because
it's really hard.
I think, between us, it's not necessarily that stuff is happening to us. Because we're leaning so far into this technology, we're also helping to shape it. Not as much as maybe Facebook and the other guys, but to a certain extent, you're all part of this revolution moving forward. And I remember I lamented, man, I wasn't around when Unix was written. I guess I missed all the cool stuff. But this is happening now. So, if you think, graph neural networks, that's for me. Well, that's not being done much right now, but if your company decides to do it, you would be on the forefront and pushing the development for all this stuff forward. So what's coming in 2020 is what everybody here and everybody wants to do.
And I think that, let's end on that statement. I know you want to talk more. You guys will be around all day, right?
Yeah.
So if you want to talk more to these guys, find them. They love to chat. Give them a big hand of applause.